So hello everyone, we are back with our second class of number theory, and in this class we are going to discuss about GCD and LCMs. You might have heard these terms, what is GCD and what is LCM. GCD is greatest common divisor, which means a number, the largest number which divides a couple of or multiple numbers, okay? Which means that if there are multiple numbers A, B, C, D, and so on, there will be a number X which is the largest number and it divides all of them, okay? So this is known as GCD. What is the LCM? LCM is the lowest common multiple, okay? So we have talked about multiple and divisors in the previous class. Okay, so LCM is lowest common multiple, which means if there are multiple numbers such as A, B, C, D, they have a multiple which is A, 2A, 3A, and so on. B has a multiple 2B, 3B, so on. C will have a multiples 2C, 3C, and so on. So there will be a point where all the numbers have a common multiple and it has the smallest value possible. So that will be known as lowest common multiple, okay, or LCM. Now, talking about GCD, you have seen this term in multiple problems, code forces, code chef, or lead code. To find GCD, the most basic idea that was discovered was taking the factorization. Okay, taking time factorization. Alright, and this will give us GCD of a number. Okay, so there are two numbers such that 24 and 36. When you write prime factors of these numbers, 2 into 2 into 2 into 3, this is 2 into 3 into 2 into 3. Okay. So what is the common value among this? 2, 3, 3 and 2. So the common value is 2 into 2 into 3, which is 12. Okay. So GCD of these two numbers is 12. So this was the approach for earlier, that how GCD is formed. But this works in root and time complexity. Okay. We have talked about prime factorization and it works in root and time complexity. But Euclidean has discovered an idea to solve this in logarithmic time complexity. How? What we can do for a GCD of any two numbers, it is equivalent to GCD of a number and subtraction of a number. Okay. So GCD of A comma B is equals to GCD of A comma GCD of GCD of A comma A minus B. So from here we have an intuition about our approach, which will be used for which will give us a logarithmic time complexity. That is GCD of AB will be GCD of B and A modulo. Sorry. Okay. So from this you can recursively solve it, and so at some point this will turn into 1 and you can return this value. Okay. So the code will look like, if you are asked for GCD of AB, if B is 1 then return A, else, or don't write else, just return GCD of B comma A modulo B. So this is code for how to calculate a GCD in logarithmic time. Now, if this is clear, we can learn something about LCM also. So LCM is lowest common multiple. Let's take for the same example. It is 2 into 2 into 2 into 3, and this was 56. So 2 into 3 into 2 into 3. So for 24 and 36, what is the number which has the common multiple? So let's write table for 24. It's come out to be 48, 72, 96, and so on. Okay. For 36, it's 72. So as you can see, 72 is common for both of them. So 72 is our LCM. Let's check how that will come. So first of all, calculate the common part. Okay. So 2 is common here. So I will write 2 until 11. 2 is common here. I will write 2. A single 2 is here. So I will write 2 here. 3 here. So this 3 is common and this 3 is left. So I will multiply 1. Okay. So if you calculate this, it is 8 into 9 or 70. So our LCM is 72 for this. Right. But do we have to do this and take a time complexity of under root n again? No. There is a formula which states that GCD of a comma b when multiplied by LCM of a comma b will always be equal to a into b. So you might have read this uh, formula, which was SCF of a SCF into LCM is equals to multiplication of two numbers in class 10 or class 12. So this from this formula we can say that LCM of a comma b is equals to a into b divided by GCD of a comma. Correct? Okay. So you can find LCM in figure of one time complexity by dividing it. Correct? Now, so this was the most basic part of GCD and LCM. Let's come to some advanced parts, okay, which very few people know about. Correct? So first of all, what I'm going to talk about is min max theorem or min max anything you can just say. I'm talking about a minimum maximum trick for any case where a number is prime factorized in this form: p1 raised to power a1 into p2 raised to power a2 into p3 raised to power a3 and so on. And the number b is represented as say p1 raised to power b1 into b2 raised to power b2. Oh, I have taken a1 here, so let's change this. The number is already a, so I can write it as something else. Let's say x1, x2, and x3. This is y1, y2, and y3, and so on. Okay. If you ask that it might be possible that a will have a prime factor of b1, but b don't have. So at any point, like a has a prime factor of 2, but we don't have a prime factor of 2, so can I write it as this? I can. So y will be 0 at that position. Yi will be 0. Okay. So if I represent two numbers like this, I can also represent their GCD as p1 raised to power minimum of x1 y1, okay, multiplied by p2 into raised to power of minimum x2 y2, and now you understand the better. Okay? It will solve. And LCM will be represented as p1 raised to power maximum of x1 y1 into p2 raised to power of maximum of x2 y2 and so on. Okay. So from this, I can conclude that, or I can say that GCD is minimum function and LCM is a maximum function. Okay, you can note that this might come at some place. Okay, we don't know, but it may occur. Now, if GCD is minimum function and LCM is maximum function, I can say that GCD of A comma B will divide A and A will divide LCM of A. Okay, so there can be A slash B and this is also B A slash B. Okay, so GCD will divide A comma B, A or B, and A or B will divide LCM of A comma B. So you can just mark this point. You may encounter it somewhere. Okay, this is theory parts. We covering theory right now. Then we will move towards some problems. So, so this was some min-max trick. Let's come to the properties also. So the first property I'm going to discuss is distributive property. So if I have GCD of some multiple m into a comma m into b, I can take that m out. So it will be m into GCD of a comma. Okay, this you know. If there is something like GCD of a comma b comma c comma d, I can write it as GCD of a comma GCD of b comma GCD of c comma d. Okay, or you can place GCD anywhere. This bracket is closed. Correct. Now the second property I'm going to talk about the subtraction property. So we know that GCD of a comma b is equivalent to GCD of a negation b comma b. You can place it anywhere. Alright. So if this is true, it implies that GCD of a comma b is equivalent to GCD of a plus minus is equals to kb, and k is any integer. Right? So this pattern comes in hand a lot of times while we are solving problems on array which require GCD, and we have a problem. Okay, I will discuss this property. I have a 1600 rated problem on code courses, and we will discuss this property there. Okay, so the third property, I won't say it is a property, but it is a consecutive case. GCD of a comma b, a comma a plus 1 is always 1. Okay, the GCD of two consecutive numbers is always 1, and you can say GCD of a comma a plus 2 is 1 if a is odd, 2 otherwise. I can write it as this. So if two numbers are separated by a difference 2, the GCD will be 1 if a is odd, else GCD will be 2. Okay. Now I will talk about GCD in Fibonacci. Correct. So if I have two Fibonacci numbers, say FA comma FB, correct? So the GCD of both will be Fibonacci of GCD of A, correct? You can verify it. So let's take two Fibonacci numbers. 2, 3, 5, 8. Oh, this is Fibonacci series, right? 13. Okay, so I'm taking 2 and 8. So GCD of 2 comma 8 will be equals to 2. The greatest common divisor is 2. Now let's check Fibonacci number of GCD of 2 comma 8, which is Fibonacci 2. So this comes out to be 2. So I can say that Fibonacci of GCD of A comma B, this is like this. Okay, so Fibonacci of A comma Fibonacci of B, when take GCD will equivalent to Fibonacci of GCD of A comma B. So these are some secret properties you need to take care of. There's one more property where you take powers. Oh, I'm what number? So powers. Let's say we have one number which is a raised to power n minus 1 and a raised to power m minus 1. Okay. There are two numbers. We are taking GCD of both of them. It will be equal to a raised to power GCD n comma m minus 1. Okay. The minus is not in the power. Okay. So these are some properties of GCD which we have. Okay. Now we will come towards the first problem. It is quite easy and we will just implement it right away. Okay, so this is the first problem, and in this problem you are given n monsters numbered from 1 to n. Initially, the health of monster I is AI. Below, a monster with at least one health is alive is called alive. Okay, so a monster which has at least one health is called alive. Until there are no only one monster alive, the following is repeated. A random alive monster attacks another random alive monster. As a result, the health of the monster attacked is reduced by the amount of points equal to the current health of the monster attacked. Okay, so this is the case 2, 10, 8, and 40. So in this problem, I will say it monsters. Okay, so you are given with an array 2, 10, 8, and 40, and at each operation, what is happening is say AI and AJ are two monsters, then AI attacks AJ. Then what it implies is AJ's health will reduce to AJ minus AI. Okay. So after this, the monster AI will have same health, and AJ will have AJ minus AI. Okay. So this is what implies, and it will happen until a single monster is left. Correct. So I will give you 15 seconds to go through this problem and try to think for an approach. Okay, then you can pause the video and just come back after that, after you have deduced the idea or you are not able to deduce the idea. Give at least 5 to 10 minutes. Okay? So I will wait for 10 seconds and I will then assume that you have get the idea. I think now you have uh, solved this problem. Now I am going to discuss it. Okay. So say there are three monsters which you have 2, 10, 8, and 40. So what will happen? Let's say there are two monsters 10 and 2. Okay. If 10 attack 2, there will be no change because it is the value is less. But when 2 attacks 10, the value of 10 will be reduced to 8. Then 2 attacks 8 again, the value will be reduced to 6. 2 attacks 6 again, value reduced to 4. 2 attack 4, value will reduce to 2. Then 2 attack 2, value reduced to 0. Correct? So as you can see, what we are doing is we are just reducing, we are taking one value as constant and reducing the other, and keep on doing that. Oh, is this the idea of GCD, where we do the same thing in GCD? We do this same thing now, where we keep one element constant and reduce the other element until it becomes 0. Or okay, if this becomes 0, then we return our value a. And for modulus thing, we if it becomes 1, then we will return it. Okay, so this is the core idea of this problem. So the I can state that minimum possible health of entire array, this entire array is GCD of this array. Let's try run on the example. So 2, 10, 8, and 40. So first I will attack this from this array. So 8 attacks 40. Then your the value will be reduced. So 8 attacks 32, 8 attacks again, it will be 24, 8 attacks again, 16, 8 attacks again, 8, and then 8 attacks again, 0. So this will convert into 0. We are asked for a random monster attacks each other. So let's attack this again now. So 8 attacks 10. So it will not be able to attack 2 because here the value is small. So this will reduce to 2. Now I can say that my monster 2 will attack 2. So 2 attacks 2, then it will convert it to 0. Now 2 attacks 10, the same scenario. 2 attacks 10, 2 attacks 6, 2 attacks 4, 2 attacks 2, and 2 attacks 0. Oh, the complete array has become 0, but only one monster left, and the minimum value that monster have is 2. Okay, you can run on multiple test cases, and the answer will be same, the GCD of the whole array. Okay, so what we have to do? We will just find the total GCD of whole array. So we will write the code. Okay, let's write it. Machine code. STD. Okay. I'm making the GCD function, which I will okay. If you can do this thing also, if b is 1, then the same thing, return a, and else return GCD of b comma a module b. You can do this thing, or you can save your stack space by using a while b exists. Okay, do a modulo equal b, the same thing which we were doing in that, swap both a and b and return after that. Okay, you can do this also. Okay, sorry, if I wrote b equals to 1, no, b we want b equals to 1, b equals to 1 in the formula. How to calculate GCD? Yeah, this will become 0 because it is modulus, it will become 0. Okay, So when modulus becomes 0, just return the particular element here. I'm sorry about that. So this is our code for GCD. Now let's write the main function. I have to take two inputs, the array of size n for loop, and I will do of the array. Okay. After doing the input, what I'm going to do, I need to calculate the GCD of the whole array. So either you can make an array, or I'm not making the array. I'm going to directly take in GCD of all the elements. Okay. So I will say integer g is equals to 0, which will hold my GCD, and I will take a temporary value x input and do GCD g is equals to. You can take the inbuilt function GCD or do this GCD because we have made it g comma x. Right? Now I just output. Right? This is the code. Let's check this if it is working or not. Let's wait and see. Okay, so it's accepted. So this was an easy problem, looking like a hard one, but when you know that identity, that subtraction, continuous subtraction is a hint for using GCD, you can just implement the idea. Okay, so this was the easy problem. Now we can move towards the hard problem, a little hard, not very. So this is the second problem. Give me a second. Okay. So this is the problem. In this problem, you are given two integers sequences a1 to an and b1 to bm, which means there are two integer sequences a1, a2, a3, a4, an and b1, b2, b3, b4, bm. For each j1 to m, find the GCD of a1 plus bj, a2 plus bj, and so on up to an plus bj. Okay. Now n and m can be up to 280. So I will give you 15 seconds again. Pause this video. Try to think about this problem. Try to form an approach. And then after that you can come back. Okay. Okay. I hope you are able to implement this problem. And if not, let's go through this together. So let's first write what I have already. Okay. So this is second problem. Uh, I will name it code forces GCD. This is the problem, and in this problem, you are given with two integer array a1 to an and b1, b2, b3, bm. Now, what you have to do? You have to find GCD of a1 plus bj, comma a2 plus bj, a3 plus bj, and so on up to an plus b. Now, you have to find for each j 1 to a2 m. Okay. Now, if you go for brute force approach, it will take a time complexity of big of n into m, and this will give you Tn. We have to deduce some idea. Hey, I have talked about one idea that GCD of A comma B is equivalent to GCD of A minus B comma B. Correct? I can reduce a value from that, from any value, and I can also reduce or add any amount of that value. Okay, so this was the key idea which we have discussed, right? Okay. So what I can do for the same array a1 plus bj, comma a2 plus bj, I can subtract this value from all the elements. So if I subtract it, it will become minus a1 minus bj, comma a3 plus bj minus a1 minus bj, and up to an plus bj minus a1 minus bj. Okay, so what will happen? This will cancel out. The bj will cancel out from all the terms, remaining the first. The GCD will look like a1 plus bj, comma a2 minus a1, comma a3 minus a1, comma a4 minus a1, and so on up to an minus a1. Now, a distributed property which we have discussed, I can take this GCD as GCD2 and separately calculate it, because this is constant, right? So I can constantly calculate this. Then my uh, formula will look like a1 plus bj, comma GCD2. Now I have to, then I can just iterate for each j from 1 to m, and then I can just check my GCD as g comma GCD of this thing. Okay, a1 plus bj, comma GCD of, I guess I have to do GCD, right? Yeah, I have to take the greatest. Okay, all the values. So output j integers. So you can just output it. Okay, don't do this. Just output it. Very clean idea and very easy code now. If you know these properties, then even a 1600 problem is very easy. Okay. Now, the pseudocode will look like, you just calculate the values. First, I can just say that my pseudocode may look like, I will take my and m as input, then take both of the arrays, array A and array B as input. Okay, after taking input, make your GCD value 0. Then first take that GCD2. How you are going to take that? Iterate from I is equals to 1 to n, and take your G as GCD of, comma, absolute difference of AI plus A0. Okay. Why absolute? It might be possible A0 is great. Okay. So your GCD2 thing is ready. This is ready. Just put it in the formula. How you're going to put it? Iterate J from 0 to m. Okay. Now just output GCD of A0 plus BI BJ, sorry, A0 plus BJ, comma, that GCD2. This printer space. I guess this is necessary because you are printing in same line. Okay. So this was the whole code. You can look at it, take an idea. So this was our 1600 letter problem, which we have solved very easily. So in this lecture, That's all from my side. We can explore more about GCDs. We will in future also going to discuss some high-end stuff and advanced algorithms also. But in this today second class, this is GCD and LCM all in just one video. We have talked about from basics and to some a little bit advanced and some functions, some unique identities, some secret formulas which less people know about. So this is it, and I will give you three problems for homework which you have to do and put in the comments that you were able to solve them or not. If you are able to solve them, put the approach in there. I will look at them and try to identify if they can be improved or not. Okay. So first problem is check if array pairs are divisible by k 1497. Okay, lead code. The second problem is 365 water and jug problem. Okay, this is an easy one. And third one is 1979 find the greatest common divisor of the direct GCD implementation. Okay, right. So these are the three problems which you have to solve. And thank you for joining in this video. And if you enjoyed, please consider subscribing. And we will meet in the next class. Thank you so much.